Okay, the idea of the division principle here. Let's start by reminding ourselves that we're trying to count the number of something. The number of structures in general would be one way of describing it. The structures can be anything, though. They could be pins, or they could be pizzas, or ice cream cones, or Olympic podiums where you choose gold, silver, bronze. Sometimes, when using the multiplication principle, where you have a number of decisions to make and a certain number of options for each one, and they're independent, we count the number of ways to construct something, but we really only want to count the final constructions. That is, if each construction has the same number of ways, m, to construct it, then we can count them all, but then divide by m. So here's an example. You want to know how many ways can you choose a committee of 2 people out of 4 total people. All right, so on the left, here's how you construct your committee. You got 4 people, and you pick 2 of them. So you pick out of the 4 people once, and then there's 3 remaining people, so you pick out of those 3 to get the second, like filling in those 2 blanks to make the 2-person committee. And that would give you 4 times 3 equals 12. But here I have a picture very shortly on the next page. Each construction can be done 2 ways, but we don't care which order we pick the 2 people in. So we can pick person A and then person B, or person B and then person A. Since there's 2 ways to construct the committee, we have to divide that previous answer by 2 and get 6 total. Picture helps a lot here. Here's a picture of my 4 people, A, B, C, and D. That's the big set. Or I could write it just A, B, C, D in curly brackets. And there's a picture of a committee. That first committee is person A and person B. So here they all are. I could have the committee made out of A and B. Notice that's the same as BA. The committee AC, same as CA. AD, BC, BD, or CD. And for each of them, it doesn't matter which order I pick them in. So if you look at the total number of committees, there's 6. 1, 2, 3, 4, 5, 6 on the left. The number of ways of constructing the committee would be 12. But we don't care how we picked, what order we picked people in. We just want to know the final result. So we take the 12 and divide out by the 2 ways of making each individual committee. I've written these as subsets, and that's exactly what we could say in general. The number of subsets is what we're counting. So here's another example. How many subsets of size 2 are there from the set U, which is the numbers 1, 2, 3, all the way up to 10. So there's 10 total numbers, and we want to make a subset of size 2. So this is like having 10 people and making a committee of size 2. So there's 10 choices for the first, 9 choices for the second, and then there's 2 ways to make each subset. Picking them in order doesn't matter. I want to divide out by the 2 ways of making each, and so I get 90 divided by 2 is 45. All right, so far we've always divided by 2. So here's an example where we divide by something a little different. How many subsets of size 3 are there out of that same universe, 1 through 10? All right, so we're picking a subset of size 3. Again, let's construct it by picking the first item, second item, third item. So that'll give us 10 times 9 times 8. Now, the number of ways of picking any given subset. I went ahead and showed how many ways there are. You can see the answer is going to be 3 times 2 times 1. So here's an example subset. It happens to be the one 392, picking those three numbers out of 1 through 10. You can build it in 3 times 2 times 1 ways because those are the orders of picking those three numbers. You could have picked 3 first, then 9, then 2, 3, then 2, then 9, 9, 2, 3, 9, 3, 2, 2, 3, 9, or 2, 9, 3. So altogether, there's 6 you can see, and the way you find that 6 ways of building that single subset is 3 times 2 times 1. And then if you divide out by that many, because basically if you count 10 times 9 times 8, you've counted 6 times too many, because we don't care about the order that we picked those three numbers. So when you divide out by the 6, you get 120 total.